In this lesson, we are going to create a haunted house. We are going to use only primitives as geometry. We are going to use spheres, cubes, stuff like that to create the house and the surrounding. And we are going to use the textures. You can already have a look to those textures in this folder. So it's static textures. We have brick textures, ambient occasion, color, normal, you know the normal. We also have the roughness. It seems that we are missing some textures, but we will see that later. We have the same door that we saw in the earlier lessons, and we also have some grass. All right, so we can use this grass on the floor. Yeah, one tip for the measurements. As we said in an early lesson, it's better to think as one 3GS unit as something. And for us, it's going to be better to think at as one unit as 1 meter. This way we can just think of a door. A door is something like a little more than 2 meters. So we can just put 2.2 or something like that to have a door that has the right size. It's just more handy. All right, about the setup, I have the setup already running. We have a sphere, we have a floor, we have some lights, and we can play with the lights as always. We can play with the intensity. So this is the intensity of the directional light, and this is the intensity of the ambient light. We have no shadows. We are going to add shadows because if we want some horror stuff, we need to have shadows, and that's all. So yeah, let's go. We are going to build the house, and we first can remove this sphere because I don't know what house can have a sphere like that. But we can keep the floor. So where is the sphere? It's right here in the house part, and we can remove this temporary sphere. And we get this. It's just to test that the light is working fine. So we're going to build a lot of things. I can do a small drawing just to think about what we are going to create. I'm going to put it on the left. So we are going to have our floor. Like this, and we are going to build our house on it. So we are going to have a very, very simple house. It's going to be a square, something like that. Yeah, we are going to have bushes. I don't know, there. We're going to have, I don't know, maybe a door. Yeah, right here. We're going to have a roof, obviously, on our house. We're going to do a very simple roof that will look like this. It's fine. Yeah, like this. And we are going to add tombstone like this. Like graves. I think we say graves. All around the house. With some randomness, we are going to make sure that no tombstone go through the house. And we are going to add lights. I don't have any colors left. Yeah, I have this one. So there is going to be, I don't know, let's say a point light here, illuminating in every direction. In another one here, every direction. And those lights will simulate ghosts, all right? We are not going to create real ghosts. We could have, but the lesson would have been too long. We are just going to create ghosts, and the ghosts will just float around and do something like that, go through the floor, get back here, come back here, go through the graves, come back here, and float around. And each ghost we have a different color, so we can have a really cool effect, Halloween effect. And we will also have one light right above the door, right here, just for I don't know, to add some warmth to the scene, to the house. Okay, I think I remember everything. Yeah. Let's go. So because we are going to have many objects to compose our house, we said the bushes, the walls, stuff like that, we are going to put everything inside a group. This way, if we want to resize or move the whole house, we can just move the group. You have to think about it before adding objects. So we are going to do house equal new 3 group. So you know, group is actually just like an object. We didn't saw that because group is made for that purpose, but you can also add objects to other objects. but it's kind of strange, like you have a cube and you add a sphere to this cube, but they are independent. It's just that if you move the cube, the sphere will also move. It's kind of strange. So they decided to create an empty object, which is named group. So you better use group, right? Then we add this group to the scene, obviously. Try not to forget this, I always do. And then we can move forward. Now that we have our group, we can create the different objects, and we are going to start with the walls. For the walls, we could have created like 4 planes, one in each direction, but instead we are going to create a cube. A cube, at least a box, will be much more simpler to create. It's handy, it's okay for performances. I know we are going to have this one and the one below right here that we won't even see, but it's okay. So yeah, let's go. I'm going to create the walls. So you can add comments. I'm going to create a group and then walls. Don't touch the floor. We can just let the floor after. And instead of creating a box or stuff like that, I'm going to call it walls, because right now we have objects that have a meaning, and we are going to use this meaning to name the variables. So I'm going to do new 3 mesh, because I will create the geometry and the material right inside the mesh instantiation. And I'm going to do new 3 box buffer geometry, like this. I'm going to use 1, 1, 1. I just want to see something on the screen, and I'm going to do new 3 mesh standard material. We are using mesh standard material just like the floor because we want something quite realistic. All right, mesh standard material is the best material to do that currently. We could have used like mesh physical material, but mesh physical material is for clear coat objects, as we saw in the materials lesson. We just need a classic material, but with good results with lights. So I'm going to use the color in the example. You can use your own color. We are going to tweak the light to have something more dark, so maybe you should do it after. And what I forgot, as always, is to add it to the scene. But we are not going to add it to the scene, we are going to add it to the house, because we have our group. Everything, every object that is part of the house will be added to this group so that we can move the whole group. So we are going to do house, add, walls. And as you can see, we have our cute little cube, which is our tiny house right here. So it's way too small and it's in the ground too. So we need to fix that. First, I'm going to make my house bigger, so it's not going to be a huge house. It's a student house. I'm going to use 4 meters for the width and 4 meters for the depth. I'm going to get something like that. All right, it's a very small house. And then for the height, well, I'm not going to use 1 because 1 meter is way too small. It's up to you, but I think 2.5 is fine. Yeah, see, 2.5. It's like 2.5 meters, so you have room, you don't bump your head in the ceiling. And then we can move the walls up, and we are going to move them up. And the value, so position Y, because the Y axis is the one going up by default on 3GS at least. And it's going to be exactly half of the height, because my house is right in the middle in the ground. So I need to move up half of the height, so it's 2.5, because this is the height of my walls, divided by 2. I get something like that, all right? Maybe it's up to you. I like to keep the calculations visible here, so I could have write just 1.25, which is fine. But if I change this one, like, I don't know, maybe it's not high enough, I put 3. Oh yeah, there is a problem, it's going in the floor. Oh yes, I have to change this one too, which is why I like to keep it this way, because if I change this one, I'm like, oh yeah, I have to change this one too. So it's up to you. I'm going to follow the example and just put 1.25. Okay, that's our walls, looking nice. And we can go further and add the roof. And for the roof, I will show you my small drawing. We want something like that. So it's a pyramid. And to create a pyramid, do we have access to pyramid inside of 3GS? Well, no. There is no pyramid shape. And for a good reason, because we can simply use a cone buffer geometry, which is this one. And as you can see, this is a cone, this is not a pyramid, but we can change the number of segments, radial segments. And if I use 4 radial segments, I get my pyramid. Cool. Sometimes you just have to use things differently to get good results. So I'm going to create a roof, const roof equal new 3 mesh, new 3, and I'm going to use this cone buffer geometry. And I'm going to use those parameters. You can try to find them, but I just tweak those parameters until I'm happy with the result. You do as you want. 3 mesh standard material. So we are also using a mesh standard material, and we are going to use that color, which is some kind of brick red color. So color, it's going to be B35F45 like this. And don't forget to add it to the house, not the scene, the house, by using house add roof. And we get nothing. Maybe I forgot something. Oh, it's there. All right. It's in the ground right here. So we need to move it up, and we are also going to need to rotate it. But first, let's try to keep our roof on top of our house. So how much do we need to move it up? Well, just fix that. Sorry. Well, the distance, you can't find the distance because as you can see, it's the center of the cone height is at the bottom, it's at the floor at the bottom of the walls. So first you have to move it up by the height of the walls. So we have something right here. So we are going to do roof position y equal, and we are going to take the height of the walls. And we get something like this. Okay, that's cool, but the center of the cone of our roof is at the top of the house. What we need to do now is add half of its height, which is 0.5, because the cone is 1 unit high. So we're going to do 0.5. All right, that's great. As always, you can also write 3 or whatever you want, it's the same. Okay, we need to rotate it now, all right? Because this is wrong, we need to rotate it. First thing you have to think about is how much of a rotation, all right? In our case, the rotation is, and let's do some trigonometry. So this is a circle. We want to rotate off. So I'm going to draw the center of this circle like this. Yeah, it's okay. Let's say our point is right here. So this is right here. We want to rotate how much? Currently, it seems that it's just an eighth of a circle. So we want to go there. So we want to do this. How much? How can we find the right value for that? If you remember, pi is doing this, all right? And currently, we have 1, 2, 3, 4. So it's a quarter of pi. I know it's kind of hard to find the right value. Usually you just test with math.pi and you find out the right result, and you think, oh yeah, that's logical. I should have known better, but it's always my case. But anyway, this is how we can find the right value. So we are going to rotate it. What we can do is just test any rotation to make sure that it's the right axis. All right, it's the right axis, so it's y, because we are doing something like that. And it's going to be a quarter of pi, so I can just write pi, math pi, and divide it by 4. And we get something like that, which is great. And as you can, maybe you remember, but me, what I like to do is multiply by the same thing, all right? Dividing by 4 or multiplying by 0.25 is the same. But I prefer to multiply. You can do whatever you want. Okay, we have a nice roof, looking great. It's getting better and better. What we need to do now is create the door. But if you remember from the textures, we just need a plane, and it's going to be a square plane. We need that, and we will put this texture with the alpha map, stuff like that, to have a really beautiful door in front of our house. So let's go. Let's create the door, which is just a plane. So I'm going to do door, const door equal new 3 mesh, and I'm going to do new 3. It's a plane, so plane buffer geometry, and I'm going to use 2, which is not the right value, but I don't know which value is the right value, because there are things happening with the alpha here, so we will just use 2 and 2 right now. I'm going to use the usual mesh standard material. We are going to use a temporary color just to have something visible. You can put any color here, not the color of the wall, or you won't be able to see anything. And we are going to add it to the house, so not the scene, the house. And I think it's fine. If I test it, unfortunately, I can't see much because the plane is below the ground in the house. We need to move it a little, and we are going to move it forward the camera. All right, so we are kind of with the camera has an angle right now, but we want our door to be here so that when we refresh, we can see the door right away. So it's going to be door position Z, and how much on the Z? Well, I can use the size of my walls, and as you can see, it's half the depth of my walls. So it's 4. Then I can just do 2, because 2 is half of 4, and I get something like this. And as you can see, we have, you know the name, it's Z fighting, because we have 2 planes battling for which one is above the other. I can show you better with that. Yeah, see? There's a problem right here. So what we can do is very simple. We can just move it a little more. It's going to be 1 centimeter. And as you can see, no more glitches, which is fine. And we can move it up a little. So it's going to be on the Y. And I'm going to move it just 1. So I'm going to respect this order, Y and then Z. Just 1 because my plane is 2, so it's half of it. And we get something like this. All right. And we will be able to add the texture on it. We can't see much, but we are going to add a light too right here. Remember, right here. Just position the things first. I think our door is ready. What we need to do now is add bushes. And this one is interesting. So let's add bushes, because the bushes will look the same. All right. It will be the same material and the same geometry. So instead of creating, we are going to create 3 bushes. Instead of creating 3 geometries and 3 materials, we are going to create only 1 and use them for the 3 meshes. It's better for performances. First, we are going to create the geometry. It's going to be bush geometry. New 3, it's going to be a sphere. Simple sphere. We have different types of sphere. I'm going to use this one. 16 by 16, which is already a lot. So the radius is currently 1, which is 1 meter, which means that we will have like big spheres. And then the material, const bush material, and I'm just going to create a mesh standard material with some kind of green color. So it's going to be 89C854. As always, if you want to test other things, you can. And then we can create each bush. So it's going to be bush 1 equal new 3 mesh. And we just start with this one. I'm going to use the geometry, then the material, like this. Don't forget to add it to the scene. I'm going to add it to the house because they are going to be very close to the house. But if they are far, maybe it's better to add it to the scene or something like that. So it's going to be bush 1, sorry. And I'm going to do, oh, sorry, there is 4 bushes. That's a lot. House add bush 1. All right, let's test that. This is my bush. So it's huge, it's below the house, so we can move it. And I'm going to move it and also scale it because we have the same geometry for every bushes, but we can play with the scale of each one. So yeah, let's go. I'm going to scale it a little. So I'm going to do set 0.5, 0.5, 0.5. So it's half of it. And then position, set. And I'm going to use 0.8, 0.2, 2.2. Yet again, you can just test values until you're satisfied. But me, I'm going to use the values I already set while preparing this exercise. We can add a second bush. So it's going to be, for the scale, 0.25, which is half of the size of the first bush. And for the position, it's going to be very close, 1.5, 1.4, 0.1, 2.1. Nothing on the screen. I forgot to add it to the house. And as we saw in the previous lesson, what you can do instead of doing a lot of add, you can add multiple meshes at once. And we get something like that, which looks great. Cool. Add the third one. So I'm going to call it 3. I can right away add it to the house. All right, don't forget to add it to the house. And then for the values, I'm going to use 0.4, 0.4, 0.4. One cool thing would have been to add it to an array, to add the coordinates to an array and then loop on this array and add all the bushes at once. Why not? You can do that. So this is the third one. And let's add a fourth one. So we added some randomness, which is cool. So I create a fourth bush. I add it to the scene and I change the scale. So it's going to be 0.15, which is really small. It's a cute bush, -1, 0.05, and 2.6, like that. Okay, looking great. So here are our bushes, and we use only one geometry for all the bushes and only one material for all the bushes, which is a good thing, good for performances. All right, let's add the graves. So as you saw in the drawing, we want to add graves like it's in a cemetery. And to do that, a graveyard, I think we say graveyard. Instead of placing all the graves manually, which would take ages, we are going to do it procedurally. It's a long term to say that we are just going to loop and place them randomly, all right? First, I'm going to add them to a group. Why not? We don't really need that, but anyway, let's do it. It's always great to organize ourselves. So I'm going to do graves and do const graves equal new 3 group and add this group to the scene. Scene add grave, like that. So nothing changed. It's just an empty group added to the scene so that we can hide all the graves at once, or we can move the grave on the side or stuff like that. So we are going to use one box buffer geometry and one mesh standard material for all the graves, just like we did for the bushes. So we can create them right away. Const grave geometry equal new 3, and it's going to be a box, but a box buffer geometry as always. And I'm going to use those size, which is the width, the height, and the depth. So it's not that deep. And the material, so it's grave material. Always choose the right names. New 3 mesh standard material. So we always use mesh standard material. It's going to be some kind of gray, which is going to be B2, B6, B1. Okay, yeah, it's very close to gray. Cool. And then we are going to create those bushes. So let's draw. It's almost the same thing as this drawing. This is our scene from the top. So we have our house here. And this is our floor. We want our graves to be positioned all around. We want them like here, like here, like here, here. I'm going to draw a few more, like here, like here, like here, like here, like here, like here, here, and here. But we don't want them here or here, and we don't want them here, 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 here. All right? In a way, we want them to be in a circle around the house, but far enough, but not too far. All right? We want them in that area right here. We are going to position things in a circle. All right? And we did that quite a lot already. We are going to do like 50 graves, 50 meshes, and each time we are going to find a random angle. So we are going to find a random angle. Maybe it's going to be here or here or here or here or here, here, here. So it's on a circle. And then we are going to move this circle further or closer by another random value. So it stays in that area, the one in green. Okay, let's go. First, we need to loop. So we're going to do for let I equal 0, I inferior of 50, I plus plus. Nice. Then we need the coordinates we just said. We need an angle, all right? We need an angle that starts from 0 and that can do a full circle. And we know how to do that. It's math pi multiplied by 2. So it's 2 times pi because pi is half a circle. And 2 times pi is a full circle. Let's go. So I'm going to do const angle equal, I will follow the example to be, it's going to be math random, which is something from 0 to 1, multiplied by math pi. So currently we have object that can be, I'm going to use the same there. So currently we have object that can be there, 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 I don't know, somewhere like that. But me, I want them to be able to continue there. So I'm going to multiply math pi by 2, like this. So I have a random angle. You can test it. It will go from 0 to something like 6 point something. And as you can see, it's going from 0 to 6 point something. Okay, cool. Then we can position our graves. We are going to position them on the X and the Z axis because this is the X axis. I'm going to draw it there. This is the X axis and this is the Z axis. Oh, sorry, it's in the other direction. So it's this one. So this is D and this is X. All right. We don't want to position them on the Y axis. This makes no sense. We want to position them on a circle around the house. So it's on the X and the Z. And we are going to use the same angle. So I'm going to do const x equal and with math sin. And I use this angle. And on the z, math cos. All right. When you use the same value on both math sin and math cos, you get a position on a sphere. And we are going to create the graves right now. So the meshes, so you can see that it's working. So let's go. I'm going to do const grave equal new 3 mesh. Use the grave geometry. Use the grave material. So right now I should have it. Add it to the graves group, not the scene, the graves group. So I'm going to do graves add grave. Careful with S or no S, singular, plural. As you can see, I have my grave looking great below the ground. And then I can move them, and to move them, I can simply do grave position set, and I have my values ready. I have the X. I don't know about the Y, so I would just put 0 and the Z. Okay, suspense. Oh, that's interesting. So it seems to be working, but they are all too close to the house. All right? It's because by default, the circle has a length of 1. What color can I use? I'm going to use this one. By default, when you use math sin and math cos, it can go from 0 to 1. So this is just 1 by default. All right? All we need to do is multiply the result from math sin and math cos by anything you want. So I can do maybe 5. Let's see. And I get something like that. It seems to be working. We have graves positioning randomly in a circle all around the house, but it lacks randomness, distance, stuff like that. So we need to fix that. It's about the radius. We put 5, meaning that our circle has a radius of 5, and we need a random radius. We need it to go from this right here. All right, so it's this distance to this distance. All right, we need it to go from this distance to this distance. And we are just going to create a new variable. I'm going to call it radius. And I'm going to use the same, it's 3 plus random, so math random, multiplied by 6. This way we get something that goes from 3 to 9. Because it can be less than 3, because we start at 3. We say it's 3 plus something. So it's going to be 3 plus a random value from 0 to 6. So it's going to be 3 plus 3 to 9. So let's use this radius instead of 5. And as you can see, we get something looking great. And it's just the right distance, so no graves can go inside the house and no graves can go outside. So it's just doing this. All right. You can tweak the values. Like if you put, I don't know, 6 and 3, we see that they're going to be further from the house. Don't go too far. And if I put 1 here, we have a slight randomness, but it's far from the house, not looking natural. So we're going to use the same values as in the lesson, which are 3 and 6. And we get something like that. Maybe it's too close to the house. Anyway, it's a horror house, haunted house. So it's okay. All right, looking great. What is the height of our graves? It's 0.8. Yeah, so we need to move the graves up a little. So maybe we can think that if it's 0.8, so this is the height of the graves, I should put 0.4. Let's do that. We are going to change it anyway, so it's looking great. And then we can add some randomness to the rotation of the graves. This is not that hard. We are going to do grave rotation, and we are going to move like this, fully, not too much, just a little. So it's going to be math rotation Y, which is this axis. So we turn on this axis, and I'm going to do math random. And as you can, I already shown you, I like to start from math random minus 0.5. This way I have a value that goes from minus 0.5 and that can go to 0.5. So it's as positive as negative. I like this. And then I can multiply it by, I don't know, 0.4. So I put parentheses all around and we get some randomness. All right, not too much. I want them to face almost the same direction. But if you want more randomness, you can just put, I don't know, 1. Yeah, as you can see, there is more randomness. Me, I like to have them all facing in the same direction. And then we are also going to move them like this because there are things moving in the ground, zombies, stuff like that. So to move them this way, it's this axis, like see where I put my camera, it's that axis. And so it's the Z. And I'm going to do exactly the same thing and look at the result. Oh, sorry. Yeah, it looks like this. So they moved because there are zombies or stuff like that moving in the ground. But the problem by doing so is that you can see below the graves, all right? Which is why instead of moving them up of 0.5, I'm just going to use something like 0.3 to make sure that doesn't move too much. Actually, you can also play with randomness on the Y position. That would be great. Okay, this is looking great. Not realistic yet, but it's looking great. Cool, let's add some lights. Or let's tweak some lights. What do we have in the lights? So where are the lights first? Yeah, we have an ambient light. All right, if I remove the ambient light, we get something like that. Okay, it's darker, but anyway, let's add it back. And we have the moonlight, and if I remove the moonlight, we get something like this, which is not realistic at all. First, let's use another color, because right now it's white. We are going to use B9D5FF, and we get something more bluish, which is better. It's like the moonlight. It's a better thing, better color. And it's too bright. We are going to use way less. It's going to be 0.12, like this. I know we can't see much, but we are going to add the ghost, the light on the above the door, stuff like that, and we'll be able to see much more. We just need a very dim light that creates an ambient thing. Okay, let's add the door light. So in the lights part, I'm going to do door light. I'm going to do const door light. So as you can see, it's not point light. Try to find variables that have meaning. And it's going to be 3 point light. I'm going to use this color, which is a warm color. All right, it's not the bluish thin color. We want some warmth in our scene, just at the center. I'm going to use 1 and 7. All right. We position it above the door. So it's going to be somewhere over here. So it's 0, 2.2, 2.7. And don't forget to add it, and don't add it to the scene. I know we added the ambient light and the moonlight to the scene, but the door light is part of the house. So we can do house, add door light. And we get something wrong because the position doesn't work. Let me check. I forgot the new. Yeah, my bad. I refresh and we get something like this. Looking great. If you wonder what are those parameters, you can get back to the point light in the documentation. And the first one is the intensity. So it's supposed to be, right here. So it's the intensity, which is a float. And the second one is the distance. At 7 units, the light is faded. All right. And we get something like this, looking great. So from behind, it's kind of bluish dark, but there is some warmth right above the door because of this light. As always, you can tweak it as you want. So one cool thing we see in horror movies are the fog. All right, we don't want to be able to see too far. And by the way, it's also bad to see the edges of our world. We want to fix that. What we can do is add fog. And the good thing is 3GS supports fog. We need to instantiate a fog class. All right, let's do that. I'm going to position at the beginning of the code, and I will do it right after the canvas. And I'm going to do const fog. You have to put it there. It won't work. You will see why. Equal new 3 fog. And the parameters are pretty simple, but still we need to understand them. We are going to choose a color. So you know what? Let's use red to start with. And here you need to choose 2 values. Let's test things. I'm going to use, 2 and 6. And to make the fog work, you need to add it to the scene by doing, I can do it like right after. You know what? Move the fog right after the scene, and then you can do scene fog equal your fog. And as you can see, we get this. Okay, it's working, which is great. But what are those values? Well, 2 is how far from the camera does the fog start, okay? If I put the camera on the ground, this is where the fog starts. It's at 2 units from the camera. If I put less, let's say 1, the fog is going to start closer to the camera. And if I put 0, the fog starts right at in front of the camera. Then, so we are going to use 1, and the second value is where the fog stops, where it's fully opaque. So we are going to use 15, which is far enough. And we get something like that, which is kind of diabolic, too diabolic. We want more like a forest fog. So we're going to use another color. It's 2628337. And it's going to be kind of bluish fog, as you can see. All right, if you're too far, you cannot see. And if you're close enough, you start to see the graves, stuff like that, which is great. Unfortunately, we have a problem, is that we can still see the edges of our scene. And we need to fix that. What we want is the same color, but in the background. And we can change this, and it's the clear color of our renderer. So take this color, go to the renderer, which is somewhere over there, and then here you can change the renderer and do renderer set clear color and use this color. So it's 2628337. I use the same color as the fog. And as you can see, it is seamless. Like the fog is doing a great job on the meshes, the geometries, the materials. And then when it's the background, well, it's the same color, so we cannot see any difference. And it starts to look great. Okay, and if we are too far, we cannot see anything, which is exactly what we wanted. Okay, for more realism, we need textures. We're going to start with the door, but first we have to load all the textures. Yeah, I know this is long to do, but anyway, let's do it. So we have our texture loader already, so you don't need to instantiate the texture loader, just move up a little in the code. And we're going to load all of them, so I'm going to start with the door color texture, equal texture loader. If you don't want to do it, just scroll on this page, and so it's not log, it's load, and you will find all this code. So it's going to be in the texture slash door slash color.jpg, because it's in the static folder in textures with an S, door, and the color.jpg. It's all JPEGs file. So I can just test this one. I don't have to log it, but anyway, if you don't have any error here, you probably loaded well. If you have an error, let's say I did the path wrong, I get an error, fix the error, and then get back to the video. So I have many of them, and I'm going to use alpha, then ambient occlusion, then I do it with you. Height, normal, it's easy to do mistake here, metalness, and roughness. It's exactly the same as before. And then we can do, take them all right, like this, like this, like this, like that, all right? Yeah, I know some shortcuts, and it seems to be working just fine. Pause the video if I'm going too fast, and get back to the video once you're done and you have no error. All right, let's go. Let's create the right material for our door. It's not going to be that easy, but we know how to do it. It's great because we are practicing. It's important to always practice. First, we don't need the color. So I'm talking about the door. So I remove the color and I rewrite everything here. Let's start easy with the color, and we are going to use the map. All right, this is the way to put a simple texture as a color for an object, and we get something like this, which is great. We can already see something. So the next one is going to be the alpha map, and I'm going to use the door alpha texture, and it's not working. Why not? We have our alpha map. It seems that it's well loaded. We didn't have any error, but still it's not working. The problem is that I forgot, as always, to use transparent true. If you have transparency in your mesh standard material, you need to activate transparent by doing transparent true. Now it's working. All the black part of the alpha map is now gone. All right, all this part is gone. Great. The next one is going to be the AO map. So AO map for ambient occlusion. And I'm going to do door ambient, it's a long one, occlusion texture. I save, no difference. Why not? Again, a problem. Well, it's because 3GS, the shaders inside the built-in materials, need you to provide a UV2 attribute. Remember this one? We need to provide UV coordinates just for the ambient occlusion map. And what we are going to do is use the current UV because it's the same UV. We just need to use the same UV. And to do that, first we need to access the geometry. So it's going to be door geometry. Then we need to add a new attribute, which is going to be set, which will be, we will use set attribute method. We need to choose a name for this new UV coordinates, and we have to use UV2. All right, you don't have a choice right now. Later in future lesson, we are going to choose different things here. And then we have to provide a new attribute. So I'm going to move it with line break so you can see everything. So it's going to be new. You can write it in one line. All right, it's just so everything fits in my screen. New 3, and it's going to be float 32 buffer attribute. And in this buffer attribute, we are going to use the same attribute, which is available at door, the UV attribute, which is available at door geometry. So this is our door geometry. Attributes, to access the current attributes of this geometry. UV, so these are the base UV coordinates created automatically by 3GS. And to access the real values, so the array, we have to use array like this. And do not forget to tell how many values compose one vertex value. And in our case, it's 2 values because UV coordinates are 2D coordinates. It's just 2. If you don't like this part, you cannot remember it, do not worry, you just have to use these techniques. And this technique, and we are going to use it multiple times, and we are just going to copy and paste it. I know it's a little hard, but anyway, we have to do it. So yeah, now it's working. Great. We cannot see much about it, but remember that you can also crank the value up. We're not going to change it. We just want to use them as they are. What we need to do now is use the displacement map to create some displacement on the door, because right now it's really flat. So we can do it. Displacement map, and we are going to use the height texture, which is this one. If it's white, it goes up. If it's black, it goes down. And if it's gray, it doesn't move. So we need this displacement map, and I'm going to use door height texture. And if I try this, no difference. It's because the height map, the displacement map, will move the vertices. And currently we don't have much vertices. We need more vertices. So to add more vertices, you need to play with subdivision, which are the 3rd and 4th parameters of the plane buffer geometry. And we are going to add a lot of them. So it's probably way too much, but anyway, we are testing things and we get something like that, which is way too much. And the door is in the shadow because of that. So we need to reduce the height effect. But still, I can show you what the subdivision did. So wireframe true. As you can see, we have a lot of vertices. All right. So we can see details. Remove the wireframe. It was just to show you. And yeah, to reduce the displacement, we can do simply displacement scale and use a small value like 0.1, which is, oh, sorry, it's not equal. We are in an object and we get something like that, which is looking better. See, we have displacement and we start to have details. So it's getting better and better. We are now going to use the normal map, which is that texture. I really like this color, which will add details, but it's like fake details. It's not doing this. It's just the illusion that the light is bouncing on those details. So we can just use normal map, door, normal, texture. Will this one work right away? Yes, it did work right away. All right. We can't see much of it right now, but don't worry, we will see those details shortly when we will have lights moving. Metalness map, finger crossed, will this one work too? Metalness texture. Yeah, it seems so. We cannot see a lot, but still no error. As always, when we will have more lights and stuff like that, you will see it. And the roughness, and you can use the door roughness texture like this. And we get this. All right, now it's working. Now you can enjoy. See those details? Yeah, looking great. Yeah, there is a clear coat on the door, which is why it's that shiny. Why not? Why not? So it's looking great. The only problem is that our door is floating above the ground, so we can just change the door size, so it will be bigger and not float above the ground. Fix it. You can use 2.2 like this. And now the door is at the right position. All right, looking great. Let's take care of the walls. It's going to be much more simple. We are going to use the bricks texture, and we only have 4 of them, which is enough. So let's go, let's load those textures. So I'm going to put the code right here. It's going to be bricks color texture equal texture loader load. So it's going to be in textures bricks color.jpg. Yeah, only have JPEGs files. Okay, cool. We can test if there is no error. No error, great. I'm going to duplicate it and rename this one ambient occlusion. Oh no, ambient occlusion again. This one normal, and this one is going to be roughness. No metalness, which is fine because there is no metal in those walls, which is kind of logical. So I'm going to do this and right here. All right, some shortcuts. I think I loaded everything right. Oh, there is an error, which is with the ambient occlusion. Yeah, my bad. This one is ambient occlusion. I did a mistake. Okay, cool. I have my bricks texture loaded. Now I have to apply them to our the walls material. So I can remove the color because the color will come from the texture. I'm going to use the map first, which is great because we can see a result fast. I'm going to use bricks color texture, and as you can see, it's looking great. We have great bricks in the walls, and we're going to add the other maps so we can have more details. So AO map, I'm going to use bricks ambient occlusion texture, which is this one here. So we have an ambient occlusion map. If I test this, it's not working. I cannot see any difference because I need to do the UV2 technique on my wall. All right. And instead of writing it again, I'm just going to copy the door geometry, set attribute, UV2, etc. to my wall. All right. Right here. Just copy this part, replace door here and door here by walls with an S. And I did a mistake. I only replaced one. Good job, Bruno. So walls and walls. I refresh and we get something like that. All right, the ambient occlusion is working. The next one is the normal map. Normal map, bricks, normal texture. Yeah, it's looking great, and we have a lot of details. See those details? It looks great. You can see the light on this part. Cool, and the last one is the roughness. We won't see much of a difference, but still we need to use it. And yeah, here we go. Actually, we can see it. See the reflection of the light? It's looking really good, really realistic. Hey, that's a nice house with a lot of graves in front of the house. Okay, that's better. Let's move forward. We can take care of the floor, and we are going to use grass for the floor, all right? So it's like in the garden with the graves everywhere. So let's load those grass textures. Can I duplicate everything? Yeah, I can just duplicate the bricks. See, it's the same textures. And I'm going to replace bricks by grass, like this. Testing, yeah. So you can just duplicate the bricks textures and replace bricks by grass. Okay, pause the video if I went too fast. Let's move to the floor. So where is my floor? It's at the end of the object of the house, I think. Yeah, that's it. I can remove the color part, and I'm going to add the map as always. So grass, color, texture. It's long to add textures. I know that, but it's important if you want a good result. And it's long to choose those textures. You won't believe how long it took me. The normal map and the roughness map. Actually, we could have duplicate what we did for the walls. So yeah, grass, roughness, texture. Let's see. Okay. What's that? It seems like it's again a tiny house and we have huge grasses, so it's not right. We need a way to reduce this texture. Oh yeah, and I forgot something very important. As always, because I have AO map, I need to do the UV2 thingy, which is this one. So yet again, I'm going to duplicate it. I go to my floor and I just add this code and replace door by floor. All right. I replace this door and this door by floor. I duplicated the whole set attribute thing and I replaced door by floor. And we get something like that. Okay, cool. Let's try to get better grasses. So first what we can do is make those grasses repeat, but be careful. So it's in the texture part. So go up in the texture part. We need to do this on every grass texture. Okay, so we need to do grass color texture. It's the repeat, which is a vector 2. So I can show you that it's a vector 2. As you can see, it's a vector 2. So we can do repeat x equals something and then y equals something, or we can do set, and I'm going to repeat it 8 times. And I have to do it for every grass texture. Like this. And what the hell is that? Okay, something happened, but it's not working. It seems that the grass got reduced, but we get a really strange result where the last pixel is being stretched to the end. This is because by default, the textures doesn't repeat. So we need to tell the texture to repeat each texture. So we are going to do wrap s equal 3 repeat wrapping. So it's going to repeat on the X. And then we can do this for every one, each texture. So this one, this one, this one. Let's see the result. Yeah, it's looking better. So we have the texture repeating on this axis. And then what we can do is repeat it on the other axis, which is wrap T. All right, looking better. I misspelled it's repeat. Like this. Really strange that it did work while I was writing it wrong. Very interesting. All right. So yeah, the warning is gone. You probably didn't have this warning because you wrote it well, which is not my case. So anyway, we have our grass looking dark, looking like a horror movie grass, which is great. Let's move forward and let's add the ghost. And we are almost done here. We have a great scene. It's looking really realistic. It's a great start, but we need the ghost to float around. As I said at the beginning of the lesson, we are going just to create light that goes to the ground and to the graves and stuff like that. So we can create them. No surprise here. I'm going to create them after the house and after the lights, actually. Yeah, let's create the ghost right here. ghost. Const ghost 1 equal, ghost 1 equal new 3, and I'm going to create a point light, and the color, you can use my color, which are kind of a funny color, but anyway, I'm going to use this intensity, which is quite a lot, but the light fades fast. The distance of the light is small, so it fades fast. And then I can add it to the scene. Maybe the house, maybe the scene. Well, in my case, I think it's better to add it to the scene. And we have something happening, but it's inside the house. So we are going to move it anyway when we can. All right, we have a ghost light inside the house. So let me check something. Yeah, okay. Let's add the other ones. So it's going to be ghost 2 and ghost 3. So duplicate. And you can use 00 FF FF, and for the third one we are going to use FF FF 00. And we have a mix of colors which are all in the house, and we need to move them. To move them, we are going to do it in the tick function because we are going to animate those ghosts. And we are going to use the same principles we did here. We want the ghost to rotate around the house like that, and also to go up and down, and to do this as different frequency. So we are just going to focus on one ghost, and once we are happy with this ghost, we are going to animate the other ghosts, so the other lights, with different values, so they don't do the same animation. So then they can cross each other, stuff like that. So yeah, let's go. We are going to use the elapsed time to animate by the right way, and we're going to focus on the ghost, so it's going to be update ghost, and we're going to focus on the first ghost. And first I want it to rotate in a circle around the house, and we did that for the graves. We're going to create an angle, so it's going to be ghost 1 angle equal, and we are going to use the elapsed time, and we get something like this. Just log this value and you will see that we get this. So it's just 0, 1, 2, 3, 4. And this is my angle. This way, the ghost will rotate naturally around, or maybe in the other way. I'm not sure of it. So I think it's going to rotate like this. All right. So this is my angle. I just use the time as my angle. Then what I can do is position the ghost. So it's going to be on the X and Z axis because I want to rotate around the house. So I will do ghost 1 position X equal math cos, and use the angle on X and on the Z, and on the Z I use sin. All right, you have to use a different on the two axes. What do we get? We get something is moving, but it's still inside the house. It's because the radius is too small. Right now it's doing something like that, all right? It's doing circle inside the house. We need to increase the radius. To increase the radius, we can just multiply it by, I don't know, 4. Yeah, 4 might be fine. Yeah, it's working. See the ghost? We cannot see the ghost. We can see its light. So it's rotating around the house, which is great. I think it's rotating too fast. So what we can do is multiply the angle by 0.5. And it's working great. The grass seems kind of wet. Why not? Maybe it rained before. And what we can do now is make the ghost go up and down. And we want to do this wave animation, which is a simple sinus. So I can use the elapsed time again. Use a different value. I would just multiply it by 3, and you will see that the ghost will go up, disappear in the floor, back, floor, back. So it's going up and down like this, which is great. So we can duplicate everything we did here and use ghost 2 like this. So if I just do that, I will get the two lights at the same position doing the same animation, which is not right. What I can do is make the other ghost go in the other direction. So I can do minus in its angle. So this is the angle of the second ghost. I can just do minus. And I will change its speed, so it's going to be slower. I will use what I did in my example, which is 0.32. As you can see, it's going in the other direction and at a different speed, which is great. Then I can change its radius so that they don't cross at the same place. So it's going to be further. Yeah, looking great. If I look there from the top, this is the one we are looking at. It's a little further, which is cool. And then I can play with other things. Yeah, I can, here I have this. So it's doing a regular sinus. What I can do is mix this sinus, so I can change its frequency anyway, so it's faster, and combine with another sinus, but at another frequency. So it's exactly the same. We add to this another wave animation, but with a different frequency, and we get more randomness. Which one is it? Yeah, it's this one. See? Just goes up, long, short, and it does something like this. We added more randomness in the animation. Okay, let's do the same for the last one. I'm going to duplicate the first one after the second one. So it's going to be Ghost 3, like this. And we are going to do the same, or it's even more randomness. So it's going to be minus elapsed time. Actually, if you want to play with this one, go ahead. I don't even know what I did exactly with those values, but it's the same principle that we just did here. But instead of using plus, I use multiplied, which add even more randomness in the value. So it's a mess. But anyway, actually I played with the radius. So this one is the radius. This is what I told you about. This is the radius. We have a fixed radius for the first one and the second one. So they rotate at the same distance. All right. In 1 hour, it will be the same distance. What I did with the third one is that I rotated at a different radius. We won't explain exactly what we did here, but it's just the radius that changed. So I can just draw, make a drawing. So I'm going to use red. Instead of doing this at a fixed radius, it's going to do something like this. All right. Which is even more creepy. And to do that, we just, instead of using 4 as the radius, we can use 7 plus math sin. So it's a sinus because, as you can see, these are just waves. So it's 7 plus math sin. So we base it at 7, which is kind of far. And we use the elapsed time with, we multiply it by any value, like this one. And we do the same for the z, with another value, and you just test values until you're happy with the result. And for this one, yeah, I can just keep the Y animation I did for the number 2, and I can change this, or it's the same, kind of the same animation. Yeah, sinus, elapsed time. Yeah, it's fine, it's fine. It's strange that I use the same one. Maybe you can tweak it. I don't know, maybe use 5 in this one and 2 in this one. Okay, more randomness. And as you can see, yeah, we have 3 ghosts playing in the graveyard, which is really creepy. So this is the new one. This is the green one, doing even more jumps in the graves. And it looks great. It's really cool. All right. What we need now is shadows. And this will be even more realistic with shadows. And we are going to activate the shadows. So we know how to do that, but we just need to practice in order to remember. First, to activate the shadows, you have to do renderer, shadow map, enabled, true. This way, the shadow maps will just start working. Then you have to go through each light and activate the shadows if you want them. So we are going to do it on the moonlight, which is a directional light. You cannot do it on the ambient light, like we said in the previous lesson. So what I will do is activate. Yeah, there is one thing you can do, and we're going to do that. Instead of activating the shadows in every part of our code, we are going to group everything. So what we did with the renderer, what you can do is that, and do shadows. This way you have all the lines of code about shadows grouped at one position. And then we will go through each light that supports shadows and do cast shadows. Cast shadow, sorry, it's singular, true. So this will activate the shadow for the moonlight. Then we can do it for the door light. I can't wait to show you the result. Then the ghost 1, ghost 2, and ghost 3. We save. Nothing yet, because we also need to activate it on the objects. And we have a lot of objects. So if you remember from the lights lesson, we need to tell for each object if that object can receive shadow, so receive drop shadows, and if that object can cast a shadow. Okay? So let's start with the walls. Can my walls cast shadow? Yes, because if the moonlight is over there, I want to see the shadow of my walls here on the floor. So walls cast shadow equal true. Can my roof cast shadow? Yes, but we won't see much of a difference because we already have the walls doing the shadow. So I don't think you need to activate shadows on the roof. Activate as less shadows as possible. So not the roof. Then the door, no, we don't care about the door. The door having a shadow, we won't see much of a difference, so not the door. The bushes, yeah, so we can have like shadows when the ghosts come close. So we can do bush 1 cast shadow, bush 2, bush 3, and we have 4 bushes, so it will look something like that. And then we have all the graves, but in our case here, we need to go back to, sorry, it's walls. I did a mistake here. So it's walls, I refresh. So it's like this. For the grave, we have to go back to the loop of the grave. Maybe we could have loop on the graves container, but I don't want to show you this right now. So it's here in the loop for the grave. You have to do grave because we want our grave to cast shadow. Cast shadow equal true. We cannot see anything yet because objects can cast shadows, but none of them can receive shadow. So we need to activate the fact of receiving shadow. And actually the only one which is really important to receive shadows is the floor. This is the one that will make all the difference. So we will do floor, receive shadow equal true. You have to test those until you're happy with the result. And see, yeah, we have shadows everywhere. And because the lights are moving, we get a really cool result when we see those shadows being animated, which is great. We are almost done. We could have activate shadows like on the walls, stuff like that, but I think it's okay. Let's keep as less possible object with cast shadow and receive shadow because for performance reasons. And yet again, for performance reasons, we are going to optimize the shadows. To optimize the shadow, we can go through each light creating shadow and change the map size, the near and the far. I will provide you those, but usually what you need to do is create helpers and find the right values. But still it's looking great like that, but it's always better to optimize those. So I'm going to do door light, shadow, map size, width equal, and it's going to be 256. I'm going to do it for the 8, and I'm going to change, so it's the door light, I'm going to change the shadow camera far. So shadow camera far, the near is fine, I will let the near. Okay, looking great. Then I can do for the ghost. Oh yeah, mixed with the cast shadow, which is not great, sorry. So I'm going to do ghost 1, the exact same thing, ghost 2, ghost 3. So we have to repeat it. It takes time, I know. So these are the exact same value for every point light. So the door light, the ghost shadow, the ghost 1, ghost 2, ghost 3, ghost 4. And at the end, what we need to change, oh sorry, there is no ghost 4. I mixed with the bushes, my bad. One last thing we can do is change the algorithm for the shadow maps. And maybe you remember how to do this. I'm going to do this in the renderer shadow map enable. Right after, it's not that important, but I want to group things together. Type equal 3, and we are going to use F, yeah, that's it, soft shadow map. And it's just better result. It's smoother. You can see on the floor, like the shadows looks even better right now. It's just better, looking great. Okay, that's cool. Well, we are done for now, but you can go further. What you can do is add new objects. A new object like walls on the sides, maybe something on the garden, maybe, I don't know, like a shovel, or maybe a hand going out from the floor. You can add names on the graves. You can animate the camera, because right now we are using the orbit control, but maybe you can do like a camera that go through the graves. Well, you can do anything you want. Go further, share it on Twitter. I would be really glad to see the new results, new houses. You can make a big house. I don't know, do whatever you want. Maybe add windows. Windows would be great. Okay, see you in the next lesson.